didn't have class. Okay, so what we're going to do is we're going to make up that time another week, not this week. We're going to make another time on a Thursday. So instead of having a full class, we'll probably have like a test on a Thursday from 3 to 4:15. Something like that. I know some of you have a class at 4:30, right? On Thursday? Something like that. So we could go like from 3 to 4:30. So for an exam period, we can do it. Okay? So for future, maybe a midterm or something like that. But for now, we're good. All right, so just to review what we were talking about pointers, right?
Yes.
Okay. How's the homework, by the way? Very successful in the homework?
Yes.
Very easy?
Yes.
Easy is good. Everybody, did you get your grades yet already for the homework? Everybody's happy?
Yes.
Okay, well, it's never happened before. It must be a brilliant class. Brilliant class of geniuses. I like it. All right, so just to review where we were coming from last time, we were looking at, you see, so n is an int, right? P is a pointer to int, and is given the value of the address of n. Okay, how many of you have been playing around with the C++ compiler and getting some interesting output, just some small programs? Okay, that's what I want to see. Play around, find out what it is. It's not a big mystery. Try to see what happens if I do this. Do it. Do it and see what happens, and you'll learn. Okay, so now, of course, when we print out n, it prints the value of n, and the value of n is 5. When we print out p, it prints the value of p, and the value of p is the address of n, which is some hexadecimal value. It prints hex, doesn't it? How do you know it's hex? How do you know? It says 0xAF3, blah, blah, blah. Okay. So that looks like hex, base 16, right? How come it knows to print hex? I mean, inside of P is just a bunch of zeros and ones. Inside of N is just a bunch of zeros and ones. How come it prints N in base 10, prints P in hex? How does it know? Huh? No. It knows because the type of P is an address. So the C++ runtime system says, convert this to hex. It says this is an int, so therefore convert this zeros and ones to base 10. So the type makes a difference. Okay, very, very good. Okay, then we talked very briefly about dereferencing pointers. You understand what is star P, right? Star P is not the value of P, which is the address. It's the value at what P is pointing at. And P was pointing at N, so what P is pointing to, its value is 5. Okay, and then we talked about references. I'm not going to spend any time on that. I'm going to come back to that as we need it. And so now what we're going to look at is we're going to look at the order of operations. So basically when we look at a more complicated expression in C++, it's going to be basically a bunch of operators and operands. What's an operand? Like a number or a variable, right? Or some expression, right? N plus 5, right? N is an operand, 5 is an operand, plus is an operator. So expressions are basically a bunch of operands, a bunch of operators. How do we decide which operators are most important? Well, basically, on top are what we call the primary operators. Primary operators are parentheses. What is parentheses? Grouping, right? Grouping. What is bracket? Array. Array element, right? What is dot? Well, if you don't know, you will soon. Member what? Member selection. If you're not sure. Okay. Now, and the last one is the funny one. This is called the pointer operator, which we haven't looked at yet. Don't worry about it for now. How many people know the pointer operator? How many people would like to know what it means? All the hands should go up. Okay, everybody should know.
I don't want to know.
Okay, so we'll come back to that, don't worry. But these are primary operators. Primary means what? Most important. So if I have a choice to do this, this, or this, I will find the primary operators first if I have them. After the primary operators, I have operators that I call unary operators. Unary operators are operators that work on a single operand. So for example, A++, N++, plus N, minus minus P. So these are working on a single operand. Also this one. Anybody know what this one is? Tilde, and tilde means not. Okay, we're going to look at some. This is what kind of knot is it? There's two kinds of knots in C++. There's logical and there's bit. This one is what? This is bit. This is bit. So you'll see what it means because it's important that we know the difference. Don't worry if you don't know. This is the logical knot. Okay? This one right here is the unary minus. For example, minus n. Opposite of n. Because there's only one. It's not a minus n, it's just minus n. So it's unary. And then we have and. This is what we call a bitwise and. This is what we call star. What is star? Sorry, this is not n. It's not n. It is ampersand address of. My mistake. So this is the same ampersand like ampersand, the address of some variable. Okay. And then star is the dereference operator. So this one we call the reference operator, gives you the address. This one is the dereference operator. It follows the address, gets the value. Okay? So again, all of the, I'm going to throw this chart up here. If you forget during the semester, or we're learning something more, go back to here. This is still very important, always. Whenever you have a question, go back to this. This will give you a good idea what you need to focus on. Okay, so now we're going to go to operators that take two operands. Those are called binary operators. So binary operators are multiply, divide, modulo, which means what? Remainder. Good. So multiply, divide. This is divide, get the remainder. Okay. Plus, minus, A plus B, C minus D. These are binary plus and minus. These are shift operators. Right shift. Left shift. See the arrows are going? You need both of them. Okay. Less than, greater than, less than or equal to, greater than or equal to, equal, equal. What is this? Not equal to. Are these logical operators? What type of value do logical operators return? Boolean value, which is true or false. Okay, now we're going to continue. This is an AND, but it's a bitwise AND. I'll show you exactly what that means. This is an XOR. XOR. Bitwise XOR. This is an OR. Bitwise OR. This is a logical AND. This is a logical OR. This is what we call a conditional operator. Question mark, expression, question mark, expression, colon, expression. Okay, so it's a conditional operator. By the way, on the very bottom here we have assignment operators. Equal, plus equal, minus equal, star equal, slash equal, modulo equal, shift equal, left shift equal, and equal, XOR equal, OR equal. Is that crazy? A lot of stuff, right? That's it. So you think you understand all of these? Ready for a test?
Yes.
All right. And then finally, the last operator we have on the very bottom is not a mistake. It's called the comma operator. The comma is an operator, and because it's at the very bottom of the list, it's the least important operator. From the primary down to the comma. So comma is very, very low. What does it mean? It means if you have 5 operators and one of them is a comma, that's the last one you're going to do. So you have to know all of these operators, what they do, to be a good, strong C and C++ programmer, because all of these operators have a meaning. Okay. So again, I'm not going to discuss them all and give examples of everything, but when I give examples, go back to this to find out how this is. Now the reason I give you this chart is because, you see this over here? You know what this looks like? It's crazy, right? It's like, who would write stupid code that looks like this? I would. And the reason I'm writing this code is not because I want to confuse you, but I want to tell you that even though it looks crazy, as far as the C++ compiler is concerned, it's perfectly fine. So therefore, every C++ compiler will look at this and know exactly what it is. So what we have is, let's count how many operators do you see here? There are 7 operators. So now that you have become a C++ genius, slowly, you're going to look at this and you're going to say, let me analyze these operators according to the chart that I saw before. The first thing you're going to do is you're going to say, remember when we had class number 1, we talked about a compiler? And Professor Richter told us what a compiler does. It's a translator from source code to object code. Now I'm going to tell you a little bit more about compilers. Because when you give this code, that line of code, that single line of code that I'm interested in right now, that single line of code, the compiler has to say that looks okay or there's an error, right? So, now we might also have a semicolon at the end, but I don't have it right now. So now, the compiler is going to do, the first thing it's going to do, it's going to identify something called tokens. Tokens. What is a token? A token is a variable, a constant, typically a variable or constant, some kind of identifier. So it's going to identify this one, I'm going to circle it, and it's going to identify this as probably an int that was defined earlier, right? It's going to identify this as an int defined earlier. It's going to identify this as a constant int. It's going to define this as an int that was defined earlier. And this as an int that was defined earlier. Same thing. Same thing. So it has identified 1, 2, 3, 4, 5, 6, 7 operands. Now it's going to find out whether these operands and the operators on the line can make an expression. So the first thing it says, assignment. Is that very high or very low? Low. Remember, very low? All the assignments were right above the comma. Equals, plus equal, minus equal, star equal, slash equal, modulo equal. This is binary, unary. Binary plus. Binary minus. Binary slash. Binary multiplication. Now, token, what is this? Plus. That is a binary plus. But then a compiler says, what's this? That's plus, and that's plus plus. This is an operator, but so is this. So you know what the C++ compiler says? I'm going to use plus plus. If one of them makes an operator, and 2 of them makes an operator, it makes that one. So therefore the operator here is plus plus. So this is a unary plus plus, followed by a binary plus. Okay, now you tell me which of these operators is highest in order. Plus plus. Because we don't have any primary operators. We don't have any brackets, parentheses, dot, arrow. Okay, but we have unary. In this case, it's going to be plus plus. So therefore, what's going to happen is we're going to draw a diagram that's going to look like this. It's going to go here and return a value. So now, b, let's say, is an int. B++ adds to b somehow and returns an int value. So now we have an int. They're all ints. Which operator is next in precedence?
Division.
Okay, so we know that we have plus, minus, slash, star, and plus remaining. So the highest order that we have actually is division and multiplication. Actually, if you go back to the chart, you'd notice that on the binary ones, those two are at the top of the chart together. What does that mean? Equally important. So therefore, if they're equally important, if there's a tie, we have to go and say, well, if they're a tie, do I take the right one first or the left one first? That's called associativity. Do I associate them left to right, or do I associate them right to left? And for this case, we will associate them left to right. So therefore, this will be the second thing that gets evaluated with a value. So far, so good? Okay. So now, what we have is we have only one operator that's the highest, which is what? Multiplication, so it's going to go here. That's going to return a value. Now, we have assignment, plus, minus, and plus. The most important one is, well, they're all equally important. So we go, in this case again, associativity is left to right in this case. So we're going to do this. So we're going to do this. So we're going to do this. Get a value. And then we have assignment. And so when we do this, we're going to assign. You know what this arrow means? Changing Y. What does this arrow mean? Changing B. You know what this line means? Returning a value. Now, notice that I was able to make a nice diagram out of this. Right? If I had another, something like this, for example, equals B plus plus, it would identify this as a token. It would say this is more important than this, so it's going to do this, right? But then it's going to expect something here with a reference where I can stick this value, and guess what happens here? That's an error. That's a syntax error. Because that diagram cannot be completed. If the diagram cannot be completed, it's not properly formed syntax. So, in our case, in the first one, it is properly formed. So what's going to happen is, all this is going to happen the way I diagrammed it every single time. And then the value that will be assigned to Y will also be returned. Is it possible that the value assigned, is it possible that the value here will be assigned to Y and then a different value will be returned from the expression? It doesn't seem logical, but it could happen. How could it happen? Well, it could happen in the following way. For example, let's say I have x plus a is equal to I. So, clearly, that's first. Clearly, this is second and this is third. So now, the question is, so let's say this is 2.8, and let's say this is 1. 2.8 plus 1 is 3.8. But I is of type int. So what's going to happen is 3.8 is returned here, but the assignment into I only puts a value of 3, and so 3 is returned because that was the value assigned to I. So you could get something different because of the type incompatibility. Okay. Question? Okay. All right, so you get the idea here, right? Now, so you get the idea. So basically, the order of the operators is important because we know how to start the diagram. And then in case of a tie, you associate left or right. Usually, they associate left to right. But oftentimes, sometimes they can associate right to left. So you got to be careful. It's usually when you expect it. Okay. Y is equal to B plus plus. Does anybody know what B plus plus means? B plus plus means add 1 to B. But it's different than plus plus B, which is below it. Actually, both of these add 1 to B. So if B was 5, on the next line here it's 6. If B is 5, on the next line here it's going to be 6. But they're different. How are they different? They're different because, let's diagram what this is going to look like. So what's going to look like, clearly, this is the most important operator. There's a side effect to B. That's the arrow showing change to B, side effect to B. returns a value, assigns to y, returns a value. If I'm going to draw this one, I'm going to draw here, returns a value, assigns to y, returns a value. Now let's suppose that b is equal to 5 and b and y are int values. B++ then executes the b++. So this operator requires the value of b to be incremented after returning the value to the expression. So the value of the expression will definitely be 5. And the assignment into y will definitely be 5, and the return value be equal to 5. If you print out this, see out this, this will actually print out the value of 5. I hate to tell you that this is going to look like this and this. It's going to print out 5, and it's going to return something which is amazing. But I'm not going to talk about that now. So now, let's look at this case. So in this case, suppose again that b is equal to 5. If b is equal to 5, this operator has the responsibility of incrementing 5 before it returns the value to the expression. So plus b returns a value of 6. Assigns 6 to y and returns a 6 here. So notice if I see out this and I see out this, the output will be different. What will be the same? Well, basically, after I execute this line of code on the next line, b is going to be 6. And when I execute the next line of code, b is also going to be 6. But notice that in the expression, b stays at its original value, and then it's incremented later. Now, let's take a look at the next expression. The next expression has an error in it, and let's see if we can figure out what the error is going to be. So what we're going to do is we're going to look at these operators. The first thing you're going to see is the fact that the compiler recognizes that y and b are tokens, and equal plus plus is an operator, and plus plus is an operator. Right? Now, which operator is more important? Plus plus or plus plus? You would think they're the same, but they're not. It actually happens that the post is more important. And you knew that, right? You knew that. You brought that information to class, which I love. So therefore, and what does that mean? It means that what's going to happen is that the parsing, once we identify the tokens and the operators, now we're going to find out, is it legal syntax? So this is most important, next, and next. So it's going to do this, and this, and this. Okay? So B++. What's B? B is a variable. It has an address. B++ means go to that address and increment the value there by 1. Suppose that B is equal to 3. What's the return value here? 3. Is it B or 3? 3. You know what 3 is? It's a constant. You know what 3 doesn't have? 3 doesn't have any address. 3 is a constant. So therefore, the compiler will try to do this. Oops. But it's going to fail. It's going to say, I can't plus plus a constant. A constant is a constant. So therefore, that's going to give you an error. And the error is going to say L value. Well, what the heck is an L value? Very simple. When you have y is equal to 3, what are you really doing? What you're doing is you're assigning 3 to the address of y. You're putting a 3 into here at the address area, right? You're storing 3 into the address of y. When you see out y, what do you print? 3. So you're not getting the address of y, you're getting the value of y. So actually it looks like y here is referring to its storage location. Store the 3 at my address. But here is saying print out my value. This can be explained very quickly in a very confusing and simple statement that says y is equal to y. You might say, I would never write code like that. I know. But it's legal, it compiles, and it works. What does it do? Listen carefully what this does. This takes the value at y and assigns it to the address of y. So the meaning of the y on the left side is address of storage of this variable is a target, and the meaning here is the value of the contents of that address. Address, contents of the address. So when we have something on the left side of the assignment, we expect to get an L value. An L value simply means the left value. It means the address. All variables have addresses. When we define a variable, we give it an address. We define a variable, we give it an address. Therefore, every variable can be on the left side of an assignment. But all variables also may have values in them. Therefore, they also have something known as an R value. What's that? That's the right-hand value. And guess what? The L and the R have to do with the size of the assignment. So if you have an L value, you have an address where stuff can be stored. If you have an R value, you have a value that can be evaluated. So that's why 3 is equal to A is illegal. Why? Because 3 has no L value. Which is address, yeah. So good. So 3 has no L value. Does A have an R value? Pretty much everything is an R value. Okay. So, if I say int pointer p is equal to the address of n, and int n is equal to 8, does n have an L value? Does n have an L value? Yes. Yes, it does. That means I can put it on the left side of an assignment. N is equal to 5, right? Okay, so n has an L value. So n, we're going to say yes. How about p? Does p have an L value? Can p be on the left side of an assignment? Yes. We can assign it a value. The value will be an address. Okay. So the answer is yes. What type is n? What type is p? In star, in pointer. And what type is star p? It's an int. Does it have an L value? Yes. Star p has an L value. Why? Because p is an address. Star p is n. And n has an L value. So therefore star p has an L value. So the compiler will let you have this, this, or this on the left side of an assignment. Okay? Does star, what is star n? Is that a legal expression or no? That's not legal, is it? No, because n has a star value equal to what? 0. You cannot put any stars in front of n because n is already an int. So you can't dereference an int. It's a pure value. Pure value. What does pure value mean? Not a pointer, not a reference to something. Pure value. So once you have a pure value, you can't star in front of it because you don't have an address. You can only star addresses. Okay, any questions about that? So you see why this is an L value error. L value, R value. So you can see that variables have L values, but sometimes even expressions like star p could also have an L value. It's not, so don't assume if an expression doesn't have an L value. Yes, it can. So we understand L value and R value, and you understand that the A has an L value and an R value. And you, is this correct or not?
No.
Because 5 has no
No value.
no L value. There is no, it's a constant. We don't store it anymore, it's just a constant. Okay, good. See how smart you're getting? I told you guys are all going to be geniuses. Okay, that's my point. Okay, now, when I write some int values, for example, let's say I is an int, j is an int, and I'm going to assign a value of 13. Now, again, I know that an int has, for example, either 32 bits or 64 bits. It's a lot of zeros. So if you like to have 32 or 64 bits, just imagine another 24 zeros in front of this, and it'll make you happy. They're all going to be zeros. But when we have a number like 13, the last 8 bits of 13 are going to be 1, 4, 8. 4 and 8 is, plus 1 is, and all the other higher values are all zeros. So you understand, a 13 is stored in memory like this, with some more zeros in the front. Now 124 is stored like this. 1, it's a 4, 8, 16, 32, 64. Now, this is a 1, 2, it's a 4, 8, 16, 32, 64, 128. If you add up 4, 2, and 1, you get 7. And this one is 8. If you add up 8 plus 7, you get, and this one is 16. If you add up, okay, so if you add up 16 and 8, 4, 2, and 1, you're going to get, what are you going to get? 31, and this one is 32. If you add up 32 and 31, you're going to get 63, and this one is 64. So you get the idea. So the reason I'm doing that, just in case you care, if you assume these are ones, 1, 2 is 3, forget about it. 1, 2, 4, 8, 16, 32, 64, 128. This is 128 minus 1 is 127 if they were all ones, but I have to take away 3. So it's going to be 124. I'm just showing you, okay? You can just do it manually, whatever you want to do. Okay, so I have 2 values. Now, notice what I have here. I have an expression. Now, this is an output operator. This is a bitwise AND operator. This is an output operator. That's a terminal operator. So how is this going to work? Well, what's going to happen is this is going to go first. Then I have a tie. So this is going to happen. Then I have a tie, so it's going to happen. And then I have this one, and then this goes, throws it away into what we call the bit bucket. This just throws it in the garbage. So I call it throws away whatever the expression get has. So the bottom line, what's going to happen here? What's going to happen is I and j, it's going to line these on top of each other. And it's going to say, if you see a 1 and a 1, 1 and a 0 rather, that's a 0. 0 and a 0, 0. 1, 1, 0, 0, 0, 0. 1, 2, 4, 8 makes 12. Output is 12. So what did we just do? We did a bit by bit AND. It's called a bitwise AND. Everybody understand? Okay, if you understand that, then tell me what's going to print out when I do cout I bitwise OR j. What's going to print out?
It's 125.
125. How many people got it? 125. How'd I get it? Everybody got to understand what? Why 125? Because an and says 1 or 0, 1, 0, 0, 0, 1 or 1, 1, 1, 1, 1, 1, 0. So all the ones here are going to stay, and this one will be additional. Okay? What's the value of I or 3? What's the value of the expression? That's an expression, right? What's the value? Let's see out. 15. That's going to be 15. Good. How about J and 3? $127. Everybody getting it? Okay. All right. Good. 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 All right. All right. So, C out 3 and 8. So this is a bitwise AND. You know what an 8 looks like, right? 1, 2, 4, 8. And a 3 looks like 1, 1. So what is the C out of 3 and 8? When you print this out, what's the value gets printed? No. 0. 0 is correct. Yes, you're correct. So that should be 0, right? Because this one has 0, 0, 0, 0, 0, 0, 0, 0, 1, 1. 1, 1, 1, 2 makes 3. No 1s, no 2s, no 4s, 1, 8. So none of the 1s line up. So when you take a bitwise AND, you get 0. How about if it was an OR? What would you get? 11. How about if you do XOR? XOR means if they're different, it's a 1. If they're the same, they're a 0. Still get 11. So take a look at this one over here. Let's do this one. 0, 1, 0, 1. XOR 1, 0, 0, 0. Tell me the value, numerical decimal value of this expression.
1, 0, 1, 1.
What's the value?
1, 0.
Close? 13. The value of the expression is 13. These two are different, so it's a 1. These two are different, so it's a 1. These two are the same, so it's a 0. And these two are different, so it's a 1. 1, 1, 0, 1. 1, 1, 0, 1. 1, 2, 4, 8, 12, 13. All right. Okay, now next we're going to look at shift operators. What do shift operators do? Shift operators, remember when a value is in memory, it's just zeros and ones. So for example, imagine that my value is 15. So I'm going to have a bunch of zeros, and then 1, 1, 1, 1. 8, 4, 2, 1. 15. So if I take that 15 and I shift these ones over by 1, the 8 becomes a 16, the 4 becomes an 8, the 2 becomes a 4, the 1 becomes a 2. What have I done? I've doubled all the values. So if I take a 15 and I left shifted by 1, that's doubling all the bits. Okay, so if I take 15 left shift by 1, I should output what? 30. So what's going to happen is, it's going to look like this. 0, 1, a bunch of zeros, then a 1, 1, 1, 1, like that, right? And I'm going to shift it by 1. And that means that, so this one is going to, so this 0 goes away, this 0 goes here, 1, 1, 1, 1, and then we have to fill this missing one, just put a 0 in here. So you can see everything has doubled, so the 15 has become 30. What if I shifted twice? What if I shifted by 2? What's going to print out? What value? Can't hear you. 60. Shifting it once doubles it. Shifting it again doubles it again. So double 30, get 60. Okay? Now, if you look at this expression, you might say to yourself, this looks crazy. How does the compiler actually know how to do this? Because if you look at this operator, parentheses are number one, right? So we're going to do that first. So inside the parentheses, we have to do this. Now, notice that this operator looks like this, very similar to this one. So, what type is this? Token. Int. Constant. What type is this? Int constant. So therefore, because they're int and int, the compiler decides that this is not the output operator, this is the left shift operator. So therefore, it shifts the number here. So the operation is shifting. Now, once you have, so that what type is the result of this? Int. What type is this? It's a cout object. What type is that? I don't know. It's an O-stream object. O-stream object. So O-stream with this operator has a different meaning. It doesn't shift anything. It's just going to output it, right? It's going to return a value. What's going to happen to this value? Throw it here, right? That's the idea. What's going to happen when we output 15 right shifted to the 1? 7. It's going to be 7, because the 1 is going to be gone. 8 goes to 4, 4 goes to 2, 2 goes to 1, 4 to 1, 7. What's going to come in from the left? An extra 0. If I write 15 times 2, and I write 15 left shift 1, what's the value of those two expressions? Both are going to have a value of 30, right? So left shift 1 tends to double, right? So which one is faster? How many people think it's the second one? Raise your hand. How many people think it's the first one? Raise your hand. And people don't know what to think. Raise your hand. All right, so the answer is that the second one is faster, but the question is why?
It's already binary. It's already binary.
But why is it faster? We're not computing anything.
The computer have to transfer into two binary first, then have to then.
They're always in binary.
Okay.
They're always in. That's the tricky thing. Is that we see 15. There's never any 15. 15 is a pretend number. It's just a visual for you, because you like base 10.
Yes.
So the question is, why is it faster? And the answer is very simple. Did we talk in this class at all about machine language? A little bit about machine language, translating right from C++ source code to machine language. Did we talk about the instruction set of a machine language? I know we did in your class there, right? Right?
What?
Don't let me wake you up, there's no reason. What I'm saying, when we translate from C++ language down into machine language, the machine language has its own instructions. They're called micro-instructions. Micro-instructions are not C++, they're not C#, they're not Java, they are machine instructions. They're the kind of instructions that can make the CPU and the ALU execute instructions. So when you write code like this, that has to get translated to machine language, which might take an instruction like this into a few instructions, or into a complicated instruction that requires several clock cycles. This one says basically take 15 and put it into a register in the CPU, and then take it and shift it by 1. That instruction takes 1 clock cycle. How fast is a clock cycle? Well, your computer runs at gigahertz. If your computer runs at 3 gigahertz, I mean, it takes about 3 billion operations. per second. So it's going to be 1/3 billionth of a second to do that. But if you multiply, that might take multiple operations on the micro level. It might take 3-4 times longer. So that's one of the things you got to be thinking about, especially when we're trying to understand speed and efficiency. Why is this faster? Because there is a micro instruction that can do it in one clock cycle, whereas other instructions are much more complicated. Multiplications, divisions, much more difficult. Which operations are the fastest in general? It's a 3-letter answer. What kind of operations are the fastest?
5-year
That is not 3 letters. But thanks for playing. Bit operators. Bit operators. Bitwise AND, bitwise OR, bitwise XOR. Boom! Those are typically executed in 1 or 2 clock cycles. Division could be like 7 clock cycles. So if you're just getting billions of them, you try to get the best operations for speed. Now, am I telling you never have to multiply by 2 again? I am not. I'm telling you, think about this for a little bit, and we can talk about the limits of this. Why do we still have multiplication by 2? But the bottom line is, these are the kind of things that you have to be thinking about as a C++ programmer to know what kind of efficiency you have available to you. Okay, now look at bit operators here. What's M? What's long? It's a type. It's what kind of type? Is it a floating point type or integer type? Integer type. Integer type. What makes it long? More bits. If int has 32 bits, this one might have 64 bits. If an int has 32 bits, this might have 32 bits. If an int has 64 bits, this might have 64 bits. It's no shorter than an int. Okay, what the heck is 0x8? What number is this? If you know the answer, you can leave the class and get an A. I don't know what number it is. What number is this? The answer is, this number is not in base 10, it's not in base 2, it is in base? It's in base 16. 0x means what follows is hex. Hex goes 0, 1, 2, 3, all the way to 9, and then A, B, C, D, E, F. 0 is 0, 1 is 1, 9 is 9, A is 10, 11, 12. So if you have a number like A7, these are the 1s, and these are the 16s. It's base 16. 1 16 squared, which is 256. What's the value of A in the 16th place? 10 times 160. 160 plus 7, so this is equal to 167, base 10. How about 3, base 16? How many 16s?
51.
That's going to be 48, 3 times 16, plus 1, 2, 3. That's going to be 51, base 10. How about A? 10 16s, 160, and 10. That's equal to 170, base 10, right? You get the idea? So, when we have this number here, what we're really saying, how many bits is this number? Each of these numbers represents 4 bits. So how many do you have? 1, 2, 3, 4, 5, 6, 7, 8. 4 times is 32. So our long is 32 bits. Our number looks like this. 1, 0, 0, 0. That's the 8. 1, 0, 0, 0, followed by 0, 0, 0, 0. That's this one. Followed by 0, 0, 0, 0. That's this one. In fact, we're going to have 7 of them. Finally, 0, 0, 0, 0. That's this one. This is a 1. This is a 2, that's a 4, that's an 8. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the what power? 2 to the 31st power, right? Maybe. Okay? If it's positive, but it might not be positive. It's probably not positive. Any questions about that? If I want you to write this number, 0110, 0110, 0110, 0110, etc., 0110, how does that number look like in hex? Six, 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 six. Get the idea? 1, 2, 4, 6, 6. Okay? If I want you to write a number that looks like this, 0, 1, 0, 1, 0, 1, 0, 1, etc., 0, 1, 0, 1. So it's going to be 0x, 5, 5, 5. What if I write the number 0x, F, F, F? What does that look like? What's the binary version of 0x, F, 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 F? Each F is 1, 1, 1, 1. 1, 2, 4, 8. 8 plus 4 is 12, 13, 14, 15. How about the number 0x, E, 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 E? What number is this? That's a 14, right? So it's going to be 0, sorry, it's going to be 1, 1, 1, 0, 0, 1, 1, 1, 0. You get the idea. Okay, that's fine. Any questions? All right, so let's take a look at this code. So the code says int n equals to 0, int k equals to 32,767. Int I is equal to 0. So I is beginning at 0. I is going to go from 0 all the way up to 31. So how many iterations is that? 32. 0 is 1, 1 is 2, 2 is 3, 31 is 32. Now, look at the code. How many of you think the code is easy? Good. Okay, 3 guys. Good. But most of you are saying, huh? So that's why I'm here. So we're going to look at this. We're going to see what the heck is this. So we're going to look at this code here. We're going to break this line here. N plus equal M and K question mark 1 colon 0. Now you might say that looks insane. But the fact of the matter is it's actually pretty sane. And it's okay. Just relax. How do you deal with something strange? You say, what's the order of the operators, and attack it that way. Now, is this 1 or 2 operators? 1. Plus equals is a assignment operator. Okay. How about ampersand? Is this binary or unary? Binary. How about this one? Tertiary conditional operator. Which one is the least important? The assignment is at the very bottom, right next to comma. Okay, so this is the least important one. So that means this is going to be more important than the conditional. So therefore, when we do this expression, the first thing we're going to do, yes? Okay, now, so what we have here is we have A question mark B colon C. This is called a conditional operator. Conditional operator looks like this. If the first thing in front of the question mark, if that expression is true, the expression returns B, but if it's false, it returns C. And so it returns a single value. You understand? So, M and K. So basically what we're going to do is we're going to return, essentially we're going to return a value of 1 or 0, depending upon whether this condition is True. True or false? I didn't hear that. Okay, so now, so therefore, what's the possible value here? 0 or 1. And then what we're going to do is we're going to apply the plus equal operator. What the heck is a plus equal operator? It means plus. First you add, get a value, and then side effect. And then you get a value. Of course, that value is going to get thrown away. So now, let's find out what the heck is going on here. So now, what we're doing is, this is sort of driving the logic, the true-false of this. Now, what's the value of m? M? You know what m looks like, right? 1 followed by how many zeros? 1 followed by 31 zeros. So that's what m is, right? How do I know that? Because it's right there on the board. And I pay attention. So what we're going to do is we're going to do m. Now what kind of operator is this? This is bitwise n. And this is k. What's k? 32767. What the heck is that? I'll tell you what it is. I'll tell you what it is. I'll tell you what it is. First of all, well, anybody know what 32767 is? It's very close to 32768, which is also known as 2 to what power?
16. But 15.
2 to the 15th power. Okay, so in terms of bits, do you know what that looks like? Because this one looks like 1 followed by all zeros. So if I'm going to put this into 32 bits, what's going to happen to the first 16 bits? They're going to be zeros. First 16 bits are going to be zeros. First 16 bits are going to be zeros. If I put a 1 here and followed by zeros, what number would that be? That would be 2 to the 15th. 2 to the 0, 2 to the 1, 2 to the 15th, which is 32768. So what does my number really look like?
0.
Somebody's a genius. Okay? How many of them? How many?
14.
60.
Plus, plus? Okay, so we have 15 of them here. 1 here. Okay, you get the idea? Do you know what this looks like? So this is the value of k. Now, when I take m and k, how many bits is the resulting of this expression? How many bits? How many bits of m and k, bitwise n? 30, 32. What are they? All zeros. And the reason they're all zeros is because m has 31 of them. So they're going to, excuse me, they're going to zero out everything on the k side. And the only one that it has, k doesn't have it. Shouldn't get excited, right? So therefore, the value will be equal to? 0. Now, 0 is a value, but we're not saying is it 0. We're saying is it true or false? When is a value true? When is a value false?
0 is false.
0 is false. Non-zero. So since the condition is false, what's the value of n after one iteration? 0. Now what am I doing? I'm shifting m to the right by, and then what am I doing with that? I'm shifting shifting m to the right by 1, and then I'm side effect m. What am I doing with m? What does m look like now?
4.
4? That's m.
0, 1, 0,
0, 1. So you understand what I'm doing. So what happens when I do this again? What's n equal to now? What's n equal to? 0. And then I do it again. What's going to happen to m? So I'm going to keep doing that. When am I going to start hitting truths? Okay, question. What will be the value when I output n? What's n output to?
1, 2,
15. 15. Because when this thing finally moves over here, you're going to have, at this point, you're going to have all zeros, right? 1 and all zeros. So these two with an and is going to go to all zeros, 1, and then all zeros. That is not a 0. Therefore, it's true. And therefore, I'm going to return a 1. So every time that 1 is shifting and hitting another 1, making a non-zero, it adds. So what's the name of this code? What's the name of this function if I wrote it as a function? Say again.
Recursive.
No, it's not a recursive. We're iterating, we're looping. But what I'm saying is, what is this function doing? It is counting the number of 1s in K. So, for example, if I cross this out and I say K is equal to 15, what's going to print out now? 4. Because 15 is 1, 2, 4, 8. Only those bits. So 15 prints 4. How about 16? 1. 16. Oh, single one. Get it? How about if I did something crazy and I said K is equal to M? What would print out? 1. Because they'll only match up on that high 1, and that's it. All right. Not bad, not bad, not bad. Whoa. Oh. It looks the same. Okay. All right. Why don't we take a short break so I can take care of my own personal problems? So we are going to start talking about classes. How many of you are familiar with the classes? C++ classes, Java classes, C# classes, classes. Okay, so classes are types. What is a class? A class is a type. It contains two pieces. The first piece is data. The second piece is actions. When we say data, what we're really saying is that means typically other words that we use a lot of times to describe the data, like properties or attributes or fields. Same thing. So data basically are the properties of something. So if a class is a type, and we think of the type as an automobile as a type, you don't buy an automobile, you buy a Chevy, or you buy a BMW MX-3, or a Chevy Cruze. I hope not, but anyway. You don't buy an automobile, you buy a specific kind of automobile. So automobile is a class. So therefore, this type, automobile, is going to have some data. And the data could be the properties that are significant for automobiles. Like, maybe the name, maybe the model, maybe the number of doors. Sunroof, true, false. So we're going to have some properties that are going to describe that particular type. And again, sometimes we use the word properties, sometimes we use the word attributes. Less often we use the word fields, but it still exists. You still see it every so often. When we're talking about the actions, it's like, what can our type do? What can a car do? Well, it can move. It can move forward. It can move backwards. It can slow down. It can turn, right? It can shift. It can open a window. It can close a window. These are different actions. We typically think of these as methods. Sometimes we call them functions. And less often today we call them procedures. But they're basically all describing things that can do. So when we describe a type, which is a class, we want to give it some properties that are going to define what it has. And we want to give it some methods that describe what it does. So a class is a type that encapsulates the properties and methods. What does it mean by encapsulates?
Hiding of data. Hiding data.
It puts a wall around it, right? Protects it, encapsulates it, puts it together. So a class encapsulates its properties and its data. It kind of protects them. Properties and methods are what we call members. So if I define a class called automobile, and I have a variable int, which is the number of doors, that's a property. Okay? That's a property, and that's a member of the class. If I have a property called make of the car, that's a property, and it's a member of the class. If I have model, same thing. It's a property, it's a member of the class. And anything that I use to describe what a car has are going to be members and properties. But actions and methods are also members of the class. So let's say I have a car, and I create an object of the car, and I want the car to start. So I'm going to tell it, okay, car, start. That is a method, and the start is a method, which is a member of the class. Why is it being funny like that? This looks a little dark, right? Huh. So there's something in here, right? I'm trying to be smart, right? They told me I was trying to be smart. All right. Okay. Now, so members are properties and methods. Now, let's talk about actions. In C++, actions can be implemented by methods, which are functions. But in C++, they can also be implemented by operators. So when you see an operator like plus, or like this, the output operator, or any of the operators we looked at, almost any of them, we could actually say, okay, this operator is not only going to be an operator in the normal way, but it's also going to be a member of our class. For example, if I take car 1 and car 2, and I put a plus between them, I want to add two cars together. Now what does that mean, add two cars together? The question is, nobody knows, unless you know. I mean, it's your class, you might know. So if we want plus, if we want to add two cars together, maybe it means the weight of the cars. Why? Because I'm interested in the weight of the cars. So if I do car 1 plus car 2 plus car 3, that expression will return the total weight of all those 3 cars. That may be important for me when I'm building a bridge. And I'll find out load. You don't care about weight, but I do. So I gave that property weight and the plus operator a meaning. So methods, which are codes, implement actions, but operators are also codes. It's just that they have funny names, like plus. But still just a name. So think of operators as methods with symbolic names, whereas methods have alphanumeric names. Classes also have something known as qualifiers. Qualifiers basically are descriptions about the class. So for example, some qualifiers may determine which other classes and objects can access this class's members. So those kind of qualifiers could say, hey, this property is private. It's only for this class. Or this property is public. Everybody's welcome to use it. So class qualifiers could be something like public, which means can be seen and accessed by everyone. So if you make public properties, you're saying you can look at properties of objects of my type. If you make them private, you can say you may not. So private qualifier means can be seen and accessed by no other class. So nobody can see these properties except the class itself. And finally, we have something called protected, which means it can be seen and accessed by some, but not all. So somebody gets special privileges, but not everybody gets special privileges. And that's going to be talking about, when we talk about inheritance with C++, protected is going to come into play. Without inheritance, protected doesn't make any sense whatsoever. So protected is really a special private for inheritance. Okay, you'll see how that works. So let's describe a class called the rational class. You guys know what a rational number is? Rational number is basically a ratio of one integer over another integer. So it's like a fraction where top and bottom are integers. So a class is rational, holds a rational number for a numerator and denominator. And this rational class that we're going to define is going to allow access to the object. It's going to allow us to access some of the members. It's going to allow for building of objects, because remember, a class is a type. But we don't want, a house is a type. You don't live in a house. You live in that house. That's an object of this type. That's another object of this type. That's another object of this type. So we have to create objects out of the types. Does that make sense? So we want to allow access to the object, constructing the object, building an object. We're going to have our rational class overload operators for plus, minus, and star. And then we're going to allow reading and displaying our objects. So we're going to build this class. So when we build this class, let's go back to our first lecture. We're going to talk about what is a, we're talking about module. So we're going to create essentially a rational module. That will be a couple files that will create the declaration for the rational and the definition of the rational. The header and the CPP. And it's going to be very hard to see. So I'm going to hit the lights all the way off. It will be helpful. See it? I'm going to just turn them off to see if that's helpful for you guys. Whoops. Can you see that a little bit better? This is not a good projector. I'm going to tell them that this connection is going to... Can you see it a little bit better? I can make it a little bit bigger. Better?
Yes.
Okay, let's talk about what we have here. So the first thing we have is this, what we're looking at right here is the header for the rational class. First of all, we have a pound include, and you know what that is, preprocessor directive. Pound includes a header file called IOStream. IOStream contains all of the objects and all of the stuff we need in order to write I/O type stuff, input, output, reading, writing, cout, cin, that kind of thing. Now, C++ also has something called namespace. For example, if I have a class which is called, let's say, rational, I might want to define it in a namespace called UB. And then I might create another class called rational in a different namespace. And if I create two classes that have the same name, that have a different namespace, then I can say use this namespace, rational, and another time use that namespace, rational. They're different classes and they could have different behaviors. So namespace simply allows me to identify classes as belonging to some greater namespace. Some greater identification or group, if you will, right? So by saying using namespace std, I'm specifying that the I/O objects coming from this header file are going to be the ones that are defined as part of the std standard namespace. Okay. Now we're going to come to the declaration of the class. You remember what I said about declaration? The declaration does not create the class or to define the behavior. It simply declares the existence of something. So let's see what we have. First, we have the class keyword. What does that mean? Class keyword basically means that this is a class declaration. And we're going to call this class rational. Open of the class declaration, end of the class declaration, semicolon. So the class is declared from here to here. Once I am starting the declaration, so first the class keyword, the name of the class, which is an identifier name, bracket, bracket, semicolon. That's enough. I don't have to have anything in here. If I can erase all this stuff in here, that's enough to make a class header. Now, it's a useless one, but it's legal. So now what we're going to do is we're going to add some of those members. On the bottom, I'm adding properties. And on the top, I'm adding methods and operators. Let's take a look at the properties first. Notice that I have a private label. Colon means label. Private label. Once I have a private label, it means everything that follows here, all the members that follow the private label are private. So I create a top int, a bottom int, and some method called normalize, which returns void, which means nothing, and takes how many parameters? None. So I have a private member method, I have a private member property, and another private member property. Up here, notice that there's a public label. Public label. Everything that follows the public is public until it hits a private. So if I didn't have this private, this too would be public. So you can have public, private, public, public, private. You can switch them. Also, I would call you a crazy programmer, but generally we have one public area, one private area. It's good enough. So, what's going on here? What's the name of the class? Rational. So tell me about the four methods that follow in the private section, or in the public section. They have the same name as the class, which makes them what kind of methods? Makes them constructor methods. So these are constructors. So this is how to build a rational object if you have no input or information. This is how to build a rational object if you only have one integer value. This is how to build it with two. And this one is a weird one. I'm not even going to talk about it yet. This is how to build a rational if you have another rational. Well, that's okay. If you have another rational and you want to build a rational, you're building one that's based on the same one as the other one. That's called a copy, right? So this is called a copy constructor. So we have, now, the constructor that has no parameters in it is usually called a default constructor. Default means I have no information, build me a rational object. What should I do? Well, it's up to us to code to define the constructor to do what it's supposed to do. That's our job. So, default constructor. By the way, this is not the default constructor code. This is just the default constructor declaration or header. That's all it is, right? Header means name, parameters, done. This is the int constructor header, int constructor header, and the copy constructor header. I'm not going to talk too much about what's in here, but you can see for sure it's a rational. So you're trying to copy a rational to build a rational. Now, continuing on, I have a method called numerator, which returns of type taking no parameters. Then I have a method called denominator that returns also an int, takes no parameters. Now, after these headers, before I have the semicolon, I put the word const. You'll see in a minute why I used const here, but what it means, it's referring to the object that's calling the method. We're saying we are not going to change the object calling the method. You'll see what that means a little bit later on. Same thing here. We're not changing the object calling the method. And I'll give a special name so that it's clear. I'll put some lights on and we'll write some code. Now, the next 1, 2, 3 lines of code are having to do with not member methods, but member operators. Now, you might say, well, how do you know they're members? They're members because they're inside the declaration of the class. That's how I know they're members. So these are constructors that are members of the rational class. This is the numerator and denominator methods that are members of the rational class. And here is the equal operator and the plus operator and the star operator, which are also members of this rational class. Tell me what this operator equals returns. Returns nothing. And what does it take? It takes a rational parameter. So if you give me a rational parameter, the equals operator will return void, which is kind of strange. Let's let it go at that and don't worry about it. Next we have the plus operator, which returns a rational. So operator plus returns a rational, and it takes a rational. Operator star takes a rational and returns a rational. Finally, display and read are also public member methods that return nothing and do something and take no parameters. Okay, does anybody have any questions on this public section of these operators and methods? Any questions? Good? No questions? Okay. So let's try to go up. So and then these. So now what's going to be very interesting is, so this file is the header file. So the next file I'm going to do is I'm going to give the file that's going to implement all this or define all these methods, and that's going to be the CPP file. Keep in mind they're two separate files. One is the header, one is the implementation. But together they work as a module. We'll call it the rational module in this case. So, we are going to look at the code. Keep in mind before we go on keep in mind that every rational object that we will have is going to have a top and a bottom, which will be our numerator denominator value. Okay? Keep in mind of that, top and bottom, that's what it means. So now we're going to go into another file. So this file, we're going to call this rational.cpp. Now the first thing we have here is we're going to, again, include IOStream. And we're going to pound include rational.h. Remember, rational.h is the header file we just looked at a minute ago. That's the file. And we're going to say using namespace standard, std. And so now what we're going to do is we're going to define some code. The first thing I'm going to look at is we're going to define I wanted to define the default constructor. I don't see it. Okay, it doesn't matter. Okay, so we'll come back to it. So we're going to go to, what's the name of the class? So when you have a header file, because it's a separate file, you have to identify what method are you coding and for which class is it. So this is the name of the class, and this is the name of the method. And this is called scope resolution operator. This says it's the rational method from the rational class, which makes it a constructor. So specifically, this particular constructor is being written for the case where we have how many parameters? One parameter. So we're going to have one parameter, and so the parameter coming in, we're going to call it a numerator. Remember what the properties are called in the class? Top and bottom. Okay, so this is a constructor. This is the code of the constructor, right? There's nothing in there. But why is there nothing in there? Because I'm doing all of my assignments in the constructor in what we call an initializer. So initializer, after the constructor parameter comes in, you can put colon, property, value, comma, property, value. If you want a rational with a value of 3, I'm going to put the 3 into the top property and 1 into the bottom. And that's going to be 3 over 1. So basically, if you give me a rational with one value, I'll give you an integer. Make sense? Okay. Now, in this case, this is a rational constructor for the rational class, but the number of parameters is 2. Int, int. That's the int constructor. This is the int constructor. Oh, okay. Never mind. This is the default constructor. So default constructor is the default constructor in the rational class, scope resolution operator, initializer colon, top property gets, and the bottom gets. So if you give me no information, I will give you a 0 over 1, which is equivalent to 0. If you give me no information, I'll give you a real 0. Now, this is important because if I didn't have this constructor, or if I didn't give it a 0, then what would go inside there? Possibly unexpected values. So constructing a default value gives you a guaranteed 0 over 1, which is equivalent to 0. Okay. Notice that GCD, this is just a what? Right now, just a prototype, right? Greatest common denominator. Don't worry about it. We'll come back to it. So this is the int constructor, default constructor, int constructor. See what it does? Top, give me the n. Bottom, give me the d. Because you give me both, I give you both. And then I'm going to call normalize. Normalize will be a special function that will basically, when you give me a numerator, for example, let's say you give me 3 over 6. Greatest common denominator of 3 over 6 is 3. So I'm going to change 3 over 6 and make it 1 over 2. Because I don't want 3 over 6 times 3 over 6 to be 9 over 36. I want 3 over 6 times 3 over 6 to be a quarter. Because I want it to reduce immediately to 1 over 2, 1 over 2. So the normalize function will normalize a fraction to its lowest terms immediately. Okay, so now, on the next line, this is what kind of constructor?
Copy.
This is the copy constructor. So it is the rational class, rational constructor that takes a rational parameter. We're going to call the parameter coming in value. Do you know what the ampersand means? Reference. Remember, parameters can be sent by reference and by value. What we're saying is that the rational parameter you're giving me, I'm taking it by reference. Which means if the object is here, I'm getting the reference to the original object. So be careful because you can change the original, but I don't want you to change the original. So I'm saying, okay, I'll take it by reference, but I want it by constant. So that means I have the reference to the real object, but I'm saying I will not allow you to change this thing. So const is protecting me from doing damage to the actual parameter by accident. I'm taking it by reference, for speed, so I don't have to keep copying all the pieces of it and making another copy of it, and I'm taking it by const to protect it from changing the original. So once I have this parameter coming in, then what I'm going to do is I'm going to start my member initializer, and I'm going to say my top property, go to the parameter value dot numerator. Remember the numerator method? So the numerator method will return the top of this object. So if this is 2/5, this will return 2 and assign it to my new object that I'm building. If this returns 5, that will return 5 and assign 5 to the bottom of this new object.
Professor,
Yes?
why don't you use regular assignments in the body of the constructors instead of the initializers?
I could. I could. So of course I could. So another way of doing that, so for example, we could say if you didn't want to have that, you could take all of this out, right? And you could say, let's take this out, and we could say basically top equals numerator, and bottom equals 1 and n. So that's the. So now I put the code into the body of the constructor. Before I had it in the member initializer list. Why? It's a little, because these are such basic things that I'm doing here, I don't even want to put anything in here because it just complicates the constructor. Even though this looks more complicated. It's not. You can only do member initializers in constructors. So if it's not a constructor, you can't say colon and then start assigning it the properties. You can't do it, only in constructors. So it's your choice. You don't have to use member initializer lists, but a lot of people are going to use them, so you're going to see them a lot. Plus it looks kind of cool. All right, so any other question? So now we're going to be at the point where we are defining the equals operator. So when you want to define the code for an operator that you are adding to as a member, you have to have the return type that matches your header file. You have to identify the class, scope resolution operator, and then operator, and then the operator symbol that you're going to use here. So the assignment operator takes a rational. What's this mean? That means you cannot change arg in here. Now, is it by reference or is it by value? By value. How do you know it's by value? Because I don't have an ampersand. How come? Just being tricky. Just to show you, okay? Usually, what would be the advantage of adding the ampersand here?
It's faster.
Faster. If you're passing a giant object, if you pass it by value, it's going to have to allocate the same amount of memory and copy everything into it. But if you pass it by reference, it's only an address. But if you make it by const reference, it's fast and it's safe, and you can't change this thing. So it's probably a better idea to go by const reference, but we did it by const just because you can do it. So basically, I want you to see what's going on here. I want you to see this operator, and I want to see what's going on here. Now, top is my property. Is being assigned the numerator method on arg, which is the parameter rational. So my rational top property is being assigned the numerator method return value of the rational argument. My bottom is being assigned the denominator method of the rational argument. Does that make sense? I'll give you some examples of how this code is going to look very shortly. So now let's continue and let's look at this operator plus. Again, operator plus is being defined in this class. This is the class. This is the behavior. This is your operator. This is the return type. When you add a rational to a rational, you return a rational. If you add 1/3 plus 2/3, you should return 1/1. When you add 1/3 to 3/3, you should get 4/3. So this return type is the value of the sum. This is the parameter that you're adding to your rational. To add, in order to add the rationals, what you need to do is you need to find the common denominator. For example, if you had 1/2 plus 1/3, what's the common denominator? 6. So it's going to be 1/2 is going to be 3/6, 1/3 is going to be 2/6, that's going to be 5/6. So you have to get the common denominator. And the common denominator you can always find a denominator by multiplying the two denominators together. So 1/2, 1/3, 2 times 3 is 6. That's the denominator. It's not always the least common denominator, but it's a common denominator. For example, if you add 1/6 and 1/3, if you multiply them, you get 18. But actually, common denominator is 6. Least common denominator is 6. But we can get there if we use our method called normalize. Normalize will get us back to the lowest one, because you can always find out the greatest common factor and then reduce everything every single time. So what we're doing here is, it's driving me crazy, this very, very bad projector. So what we're doing here is basically, we're going to create, so this is the beginning of our operator plus code. Okay, don't breathe. I told you not to breathe. I think it was him. He's breathing very heavily. Can you keep him in check? All right, now you're just playing games. All right. So what we're doing in the code is, what is this? This is the rational type. What is this? This is an object. So we're creating a rational, and we're putting it, basically, this is going to be a constructor. Numerator is my numerator value, top, times the argument denominator plus
Professor?
arg numerator times denominator.
Professor?
So what is all of this? Yes? Yes?
Yeah.
Yes?
The arg which you have mentioned in that parenthesis is referring to an object of rational class?
Here?
Yeah.
This is a parameter, which is a rational object.
Okay.
I will show you some exact code in a second. Okay, so all right, let's skip this for a second. We're going to skip it. Okay, so now let's take a look at this one. So this is the numerator method from this class, returns an int. So if you call numerator, you're just going to return the top. You can't say, give me the top, because it's private. But you can say numerator, and that will return the top. So you can read it, but you can't change it or write it. Yeah. Denominator method from the same class returns the bottom, which makes a lot of sense. Multiplication one, you want to multiply. So let me show you some code. Let's see. Either I will show you, or we have some code we're going to look at. This is the normalize method. Okay, so this is the normalize method. Normalize basically gets the GCD of top and bottom, and then divides the top by the denominator and by the GCD and the bottom also. So for example, if the GCD of 3 and 6 is going to come back as, what's it going to come out? It's going to be 6, so that it's going to divide it by 6 and by 6. Okay, you get it? And so it's going to divide this. And GCD is just a function that will do it. This is just a simple function to get the greatest common denominator. You don't have to worry about this function. But this is just the code, just in case you need it. Finally, if you want to display your rational object, you can do a cout. Where's the cout coming from? Coming from IOStream. So cout top, output slash, output bottom, output new line. Very simple, right? Display. Copy. Not going to worry about copy right now. It's too weird, too complicated. Don't want to scare anybody just yet. And then we have a read method. If you want to read a rational, what you're going to do is you're going to use the cin object, which takes standard input. And you're going to input an int into the top, and another one into the bottom. So it's going to read, and those two values are going to come into those properties. And then you're going to call normalize. And normalize will do what? You'll get the GCD and divide them both by that. Okay, so I want to show you some code. And I want to be very specific about this code. I'm going to make it a little bit bigger so we can see it. That is bigger, huh? That is big. Don't ever say I didn't make the stuff big enough. Might not be bright enough, but that's his fault. He keeps breathing. All right. So what we're going to look at, we're going to look at this code, and I want to look very carefully about what's going on to make this code work. So the first thing we have is, this is a main program, right? So basically, how does this work in your C++ project? Well, basically, your C++ project has CPP folder, right? And has another H folder, right? So you're going to put here rational.h here into this folder. You're going to put rational.cpp here. That's the one we just looked at. And then you're going to put this one. This is going to be another file, whatever you want to call it. I don't know. You can call this whatever you want. I can call it driver.cpp. And this driver is just, that's it right there. So what you want to do is, once you do that, then you want to compile and run your project. So we'll compile it, link it, load it, run it. And it will start executing at the main method. There's only one main method. There's nothing main here, right? So you need both these things. Okay, so void main bracket, parentheses bracket. So this is the code for the main. That's all it is. So rational P, what am I doing here? I am constructing P to be a rational object, constructing it using the int constructor. So what's going on, am I defining P right now? Yes. So what's going on right now is P is being put into memory, someplace in memory, and 3 and 4 are its values for top and bottom. I'm doing the same thing with Q. I'm defining Q to be another object with 2 and 3 as the top and bottom. I'm putting R in memory with 2 and 5 top and bottom. And then I also have T and U, but I'm not giving them any constructor parentheses. So therefore, the assumption in C++ is that's a default constructor. So therefore, what is the look of T? T is what?
0 and 1.
0 and 1. And U is 0 and 1. Does everybody understand that? So that's what I did here. Now, do you remember that when we called the int constructor, we passed in these two parameters, and then we grabbed those two parameters and we set them top and bottom to them using the member initializer list. Member initializer list, okay? Right? We had something like this. Top, whatever it was in here. So it was like top this and bottom something else, right? And then we had code was empty. That's what we did. And I told you we could have done it differently. We could have said top is equal to whatever this is, bottom is equal to whatever that is. Okay, now I'm going to go to this line of code. T is equal to P plus Q. So what we're trying to do is we're trying to assign into T the sum of P plus Q. So I'm trying to add 3/4 plus 2/3. That's the logical stuff that I'm trying to do. What's the least common denominator?
12.
It's going to be 12. So how many 12s is this going to be? 9. And how many is this going to be? So together? So this should return what? 17 over 12. That's what we're looking for, right? Okay. So let's take a look at P plus Q. So I am going to say P plus Q is going to return a value. Now if you remember, and of course this value is then going to be assigned here. And normally you would expect this to return a value, but it doesn't. There is no expression here. This is dead. Why? Well, you'll see in a second if you don't recall already. The bottom line is P plus Q. So that's what we have to do first. So the compiler says you're a token, you're a token, you're a token, operator, operator. Which operator is more important? This one. What's the meaning of plus? The meaning of plus is plus followed by an object of type rational. When you have an object of type rational followed by a plus, followed by another rational, that's the case where the object is calling on the plus method and sending Q as a parameter. This is a call to a method that we coded in CPP file where this object is invoking or calling this behavior, this operator on this parameter. Now, what type is this? Okay, what type is this? Okay, so we have to distinguish between these two rational objects. This P right here we'll refer to as the host. And this is an extremely important name. Host is referred to the object that's invoking the behavior, the host object. So if P is the host object, what is Q? Q is the parameter object. They're both of type rational, but they're different objects. So listen carefully. This parameter object is going to come into the program through the parentheses of the method or operator. But the host doesn't come in at all. It's always there. If you go into the code for the plus operator and you see somebody say top equals, it's always top of the host. But if you want to get access of top of this one, you have to refer to it by its name from the parentheses, dot top. So in the method, top, which is a property, is always the top of the host. Bottom is always the bottom of the host. If you want this one's top or bottom, you have to specify the name of that parameter in the parentheses, dot top, dot bottom. So the host is, we say we access the properties of the host implicitly. We just say top, bottom, top equals, bottom equals. Bottom of what? This one. So, this is the host, this is the param, and that's the method. Notice that there's no parentheses. It's kind of strange, but this is really a method. Actually, C++ allows you to write this code a little bit differently. You can write this code like this. You can say T is equal to P dot operator plus param Q. So C++ will actually allow you to write the code. P is calling operator plus, sending parameter Q. This looks very much like a method call, but a very strange name, but a method call, because you're selecting, dot is member selection. You're selecting the operator plus member method, passing in Q. Now, which way do you like better? This way or the way it's up here? This way. You like this way better? Most people like, well, this is
More understandable.
it's more understandable. But once you understand that this is the same as that, that's so much cleaner. Right? It's cleaner because that's like, makes sense. P plus Q, assign it. So a rational is equal to a rational plus a rational. Now, if we didn't have the plus operator declared in the H file and defined in the CPP file, this would be a syntax error. Because the C++ compiler would say, I don't have any plus operation for a rational with a rational. Error. But because we define this operator in the context of being a member of this class with this parameter. Now, if our parameter, for example, let's say this class is P, right? Rational. And let's say this class was, let's say we had a different type of object called real number, okay, whatever that means. So that would be rational dot operator plus real. Do we have any code for that? That would be a syntax error. But if we added another operator plus for a real, that would be executing that code. So we define the code for the operators and the parameters that follow them. Now, what kind of operator is plus? Unary or binary? Binary. So you cannot write the code, for example, P plus Q T. You can't write that code because that code is wrong even if P, Q, and T are ints. You can only write code that makes sense in the syntax of the language. So this is wrong, wrong, wrong. It doesn't make any sense. You cannot write P dot operator plus QT. So you can't say this. This is also wrong. Why? Because P is irrational, plus is a binary operator. You're giving me 3 operators. No. So you can't define a binary operator to become a tertiary operator, 3 operands. Can't do that. You can take a binary operator and say, the host is going to be this type that you don't know about, and the parameter is going to be this other type you don't know about. You can do that. You can change the binary parameters coming in, but you can't change the number of them. So you can override or overload the operator, but it has to be done within the syntax of the language. If it doesn't work for ints, it won't work for anything else. If it works for ints, it will work. For example, let's say you wanted to have a code that looks like this. So you created your P, and you said P plus plus. Now P is a rational object. Plus plus, this is not going to be compiled successfully because plus plus, it does not work because P is what type? Rational. And the guys that wrote C++ compiler never heard of a class called rational. So there's no code, no behavior for plus plus. But if you overload plus plus as an operator in your class, it's okay. Because P plus plus will work syntactically just like I plus plus works when I is an int. So if it works with an int type, it'll work with a rational type as long as you define it. Okay? So I plus plus, if I is an int, and let's say R plus plus, where R is a real number, those are different codes. But they both increase the value. This increases a 4 to a 5. This increases a 4.1 to a 5.1. They're different codes, aren't they? But they look the same. So how does C++ choose which code is? It looks at the operator and it looks at the context. What type is this token? Oh, it's a floating. Okay, I'm going to use this code. What type is this? I'm going to use that code. So the context where that operator is used is very, very significant. So you can overload virtually all, not all, but virtually all operators, but you have to overload them so that they look and are used in a similar fashion as they are in standard C. Not plus plus, just C. Because most of these operators are originally part of C. Not all. We have a few extra ones, right? Okay, so I think everybody is aware what's going on here. So let's kind of review what we said. So what we're saying here is that
Professor, what about trying to add more than 2 rational objects, like P plus Q plus R?
Okay, so that's a good question. I'm going to address that question right now. Plus R. So the question, can that work? The question is, can it work with ints?
Yeah.
Yes. So therefore, what's going to happen here, this operator will, so the first thing C++ does is tokenize it. Token, 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 type, 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 operator, 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 syntax tree. Syntax tree is going to be not important, more important, more important. It's going to do this, 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 correct? And then it's going to see, does this work? So it's going to say P plus Q. What's P? Rational. What's Q? Rational. Oh, I have a rational plus overload for this type that takes this parameter, and that returns a type rational. This rational, again, is being selecting the plus operator with another rational, so that, again, selects the rational. Now I have a rational equals a rational. If you recall, we had an overload for the assignment operator. Remember that? So in our assignment overload, we had basically the host was given the values of the parameter, and it returned void, which means that there is really no return value here. So therefore, there's no return value, so the semicolon says, okay, I'm done. But there's nothing to return.
But if instead of R we have constant, and then that
R
is like true or tree, whatever.
Okay, so what if you, okay, so you're satisfied with my answer?
Yep.
You believe me? You're buying all this, right? I'm telling you. Any questions? So what if we had plus 3? Which makes logical sense. Okay, so what's going to happen now? Now you have to think, well, can that work with ints? Well, yeah, you could say int is equal to int plus 3. So it might work. Doesn't mean it's going to definitely work with rationals, only if the code is there. So the syntax diagram is going to look exactly the same. The only difference is that the token type here is not a rational, it's an int. So after evaluating this, a rational, you're going to get a rational. So you're going to have a rational, which is going to be, let's just say, q plus 3. And the question is, does that pass the compiler with the code that we have? And surprisingly, the answer is yes. That's why it's surprising. See what I mean? Okay, so surprisingly, the answer is yes. And the reason it's yes is like, how in the world can it succeed? That makes zero sense. It goes against everything you told us, right? All right. And the reason is because this expression, I don't know what happens to it, is definitely going to be this, right? So that's going, so again, token, operator, I have an operator overloaded for rational objects, rational class. And it takes a rational. But you're not a rational. You're a 3. But I know how you told me that you can make rationals out of ints, because you're an int. There is an int constructor for rationals. So what's going to happen is C++ will actually call the rational constructor with 3 on this thing, turn it into a rational, 3 over 1, add it to Q, return a rational. Now, if you said 3.1, I can't turn doubles into rationals. But you could write that logic in 2 if you wanted to. You understand what I'm saying? So basically, so the reason that this is surprising that it works, it's very cool. Now, if I didn't have the int constructor, it wouldn't work. If I only had the default constructor and the int constructor, it wouldn't work. But because I have the int constructor, C++ says, I have a rational plus for this rational host with a parameter of rational. What type is this? Int. Do you have a way to turn an int into a rational? I have a constructor. So it's a little surprising, right? And actually, sometimes it might be like a little scary because you could get results like, I didn't expect these results. The programmer wrote bad code, but the C++ ran anyway, and it succeeded, but I don't know what that results mean. Interestingly enough, sometimes we don't want the compiler to do this. Sometimes we say, hey, don't do that. Just because it's a 3, don't think you can make a rational out of it just because you want to. I want constructors, so I will use them when I call them. I don't want you calling them because you think you know what to do with them. And that's when we use a special keyword in C++ called, anybody know? Explicit. So we can modify a constructor with the keyword explicit. And what that means is a constructor is explicit meaning that it can only be called programmatically by us. It will never be called by the compiler to convert. So it's an explicit constructor. You have to actually call it. You can't just imply to the constructors. See what I'm saying? So again, it's a very advanced concept, but it's a very important concept. So if you have an explicit constructor, you're saying don't convert anything, because if you have a constructor for a double, constructor for an int, constructor for a real, whatever, then if it finds a real and it says, well, I know how to make that into a rational, if you make those all explicit, then it will not utilize those. So in that case, if you made that int constructor explicit, that would be a syntax error or a warning or an error saying there is a constructor but it's explicit. I don't know which error you're going to get. Where does explicit go? Explicit just goes explicit, rational, colon, rational, colon, int. Just, that's it. It's an explicit constructor. It's a great thing. All right. Believe it or not, I could spend the rest of this class talking about this slide. Actually, I can spend the rest of the slide talking about this statement, and I think I will do that. You are not going to believe what kind of crazy stuff is going on behind that statement. You're just not going to believe it. And I want to try to get you out at a reasonable time. We like 5:15. I think we voted for that, right? That one, I think it was unanimous. I think he voted against it. He wanted to stay till 5:35. Loves the class. All right. So I want to remind you of a couple of things. So in order for me to spend more time on this one slide, I have to go back a little bit of the code and remind you what we're looking for, so that you are seeing what I want you to see. So specifically, I will rewrite the statement: T is equal to P plus Q. So how many methods are going to execute? Methods. Let's say it said methods. Or operators, which are
3.
methods. How many are going to execute?
3.
3.
P and Q, and then the value gets.
Well, P is not a method.
P.
Methods.
Some constructor.
The addition method and the assignment.
What I'm saying is how many methods that we have in the CPP file will be firing on this date. The answer is 4. That's why I can spend the rest of the class on this. 4 methods are going to fire this. Like, are you serious? Do I look like I'm not serious? Do I look like I'm pulling your leg? I am not pulling your leg. Okay. 4 methods. So let's find out why 4 methods. So let's see what's going on here. So we're going to do a very simple syntax diagram. Clearly, by syntax, these 2 tokens are added, assigned into here, and maybe a value is returned. So the first thing that happens is this plus is determined to be an overloaded operator from the rational class, which is the host. So P is the host, this is the operator, this is the parameter. Let's go to the code. Let's go to the code of the plus. I love the code of the plus because it's so interesting. Okay, so this is the code of the plus. You see it? This is the code from here to here. Okay. I don't even care about this part of the code. I just love this part of the code. Now this, you understand what's going on. So now you understand when I say P plus Q, P is the host, Q is the parameter, Q is arg. Arg is Q. By value or by copy?
Value.
By value, not by reference, right? By value. By value. So, I am creating a rational object called temp, invoking a constructor that calls numerator. Numerator of what? Yes. Host. Host. So this is the, which one? P. So when I say numerator, that's the P. That's the P numerator. That's the host numerator. Times the denominator of Q plus the denominator of numerator of Q times the denominator of P, the host. And that gives me the top. All of this just gives me the top. This is just a calculation, comma, top. The bottom is just going to be the denominator of the host times the denominator of Q. And that's going to give me the bottom. That closes the constructor, and I simply return temp. It's not a good code. I should say normalize, then return. I'm sorry. It's easy to change. Okay, so everybody understand? You understand there's only two statements here. Constructor with some crazy stuff inside. So why'd you write it inside? Because I can't. So constructor with some crazy stuff inside, and then just return. Create a temporary and return. Okay, so you would think that's the only method that executes. You would think that's the only method that executes, but you'd be so wrong. Because there's three more methods you're going to execute. Actually, one method is already executed before you realized it was executing. So before we actually got to do this code, we actually executed another method. Like, what? Does anybody know which method executed before the plus? And I'll give you a clue. It's not obvious. It's not obvious. Anybody? If you give this correctly, then you can just take an A and just leave. Take an A and just go away because it's going to bother everybody else. Nobody will like you.
Before plus.
Before plus. There's a code that executes before plus that we wrote. Okay, last chance. You want an A? He doesn't want an A. Okay. All right. So now I'm going to show you a little bit behind the scenes. So basically, what we have is we are now, our driver program here has this object P, right? And this object Q, right? So now we have a call, if you want to think of it, P dot operator plus Q. We're invoking this method. This is the operator. This is the code. Now, that's better. It's killing me. Okay. Okay. This, you see this parameter? This is, we call it, is this a formal parameter or the actual parameter? The actual, the host is the actual host. Q is the actual parameter, but arg is the formal parameter. Okay, so now its name is arg. How is so arg is a name. And how are we passing this Q into the plus? We're passing it by reference or by value? By value. What does that mean? It means we're copying it. So that means we have to copy. What does that mean? It means that we have to make another object and copy tick, 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 tick. That is the job. So the copy constructor had to, and where's the copy constructor? Oh, it's someplace here. Let's find it. Copy constructor, where are you? It's gone. Oh, hold on a second, I gotta make it smaller before I can make it bigger. The copy constructor is right here. What's a copy constructor? A copy constructor is one that copies parameters by value for classes. If you don't define one, you get one defined for free, but if you define it, it has to take the same type as the constructor, class, constructor, parameter, and the parameter must be taken by const reference. If you write a constructor that takes the same type by const reference, you are overriding the default constructor. So whether you override it or not, there's a default constructor. There's a copy constructor by default. But we're overriding it. So that means that this one, basically, so what happened was, as we are passing Q, ARG is the formal parameter, and therefore we're copying Q into ARG. So tell me, what is top referring to? Top of what? Which is the parameter that which is the host of top? Q? No. No, we're copying from Q. The copy constructor is copying into Q. So it's the top of Q gets the value of the numerator. What is value? That's Q. That's Q. Q is being passed by value, so Q is the parameter. So we're taking the parameter fast, but we're protecting it by constants so that we don't change it. That's why it's constant reference. You have to take a same parameter as the constructor by constant reference, and that's the copy constructor. So value.numerator is the Q numerator, and then value denominator is the Q denominator, and we're using a member initializer to set arg bottom to the bottom of the Q, and arg numerator top to the Q numerator. Does that make sense? And so whatever the values of Q, so basically what this does, that's what that happens. Okay, you with me so far? So now, so you can see that the first thing that executes is the copy constructor. Right? Now we're going to execute the plus. So to execute the plus, we have to jump to the plus method. Where is it? Should be here someplace. This is the plus method, right? The plus method is going to create a temporary object. That is now going to execute the int constructor. So we are now going to execute the int constructor. That's the second method that's executing right now. That's our method up here someplace, right? Okay? And then we're going to return temp. Return temp. Temp is a rational. We return our... How do we return it? So we have just finished executing operator plus, but now we have to return temp. How are we returning temp? By value or by reference?
Reference?
No. If we return it by reference, it would have to be like this. We're returning it by value. Guess what? What?
You copy it?
Copy constructor. I'm going to have to copy temp into another location that's going to be over here. So I'm going to, and I don't even know what the object is going to be called, but I'm going to use, number 4, a copy constructor. Yes, I am. And I'm not done yet. There's a 5th method. I forgot. I didn't really forget. I just don't count very well to 5. So now, once we do that, this part of memory is left off, and then this one is here, but Q is here. Q hasn't been changed because the code we had, or T, right? T is, forget about T. T is up here, right? T has not been assigned this value yet. Until we have this. But this happens to be one of our methods. And that method is right here. So when you see the code T is equal to this, T is being assigned to whatever is the return value from here, and the return value, this is where the copy constructor writes it, right? That's the temp. That's being returned from here. Now we have T is equal to a rational. That means rational equals rational. And that means this is the host is rational, equals is the operator, and this is another one. So how are we passing the parameter here? By, so we're going to execute the copy constructor. The copy constructor has to be passed to another one called arg. I'm sorry, but it's a different arg. So we have to copy this in here. That's the fifth method. And then, what is top referring to? Top of the host. Who's the host?
T.
So T top, which is the host top, gets arg numerator. So that's, now we're executing the code of this. So the sixth method is the operator equals. Yes, it's true. It's really true. And if you don't believe me, because a lot of people don't, and I really don't see why you should either, but if you put hello from this method, hello from that method, see how many of these methods you see hellos. You should see 6. Now what's significant about that, I don't know what you can see. I can't see anything. Can you see that? I mean, I know you have better vision than me because you're young and beautiful, so that's always helpful. So 6 methods. Why is that significant? Well, it's significant because every time you call a method, and we're going to get into that, but every time we call a method, we have to jump from the current address that we're executing. We have to save the state of our method, start another method on a stack, do that thing, jump again, and when we return, we have to restore from the stack back into execution. This is called method call overhead. Every time we call another method, it takes time. So this is extremely inefficient. Wow! So inefficient. It's crazy. Right? So we are actually executing 6 methods. And you thought we're only executing 1. You can see why sometimes people say that object-oriented programming is a little bit slower. You see what I'm talking about? So we have added to the slowness, but what have we gained? We've gained the beauty and simplicity of T is equal to P plus Q. It's so beautiful. Irrational is equal to irrational plus irrational. That's how we want to think. This is what happens. Now, in reality, what I should have done, remember I told you that this is really not returning anything? The reason I said it's really not returning anything, because if you look at our overloaded equals, it's returning void. But if I change that and I return rational, then I need to return something here. And what would I return? Well, let's think about that. I'd have to return this object.
The host.
The host. Yeah. So, thank you. So, when we are inside of a method, there's always a pointer to the host. And the pointer to the host is called this. Unfortunately, I'm trying to return a rational, so I cannot return this. I don't want the pointer to the rational. I want to actually return the rational. What should I do? I want to return. I don't want to return a pointer to the rational host, but I want the actual host. How do I do that? How do I return what a pointer is pointing to? Oh yeah, I can dereference it.
Yes.
Oh man, okay. So if I return this, that's a compiler error. But if I do this,
Yes.
look at this, even the lights came on and says, yes, yes, we'll give you blue. Everyone will see and be happy. Return star this. What is this? This is a pointer to the host. It's a pointer to rational. It's a rational star. What is this? This is a rational. What am I supposed to be returning? A rational. We're in business. So if that happens, then what happens here is, you see what happens here? Now we have this. And what's significant about that? If I went to do cout of this, then cout would actually output and print out. Look at this. It's like such a dramatic ending to the class. You'll never forget this, right? We're actually going to output the value of this return t, which is very exciting. Don't look at it. Don't breathe. Okay, so that's pretty cool, I think, that we can do that. Now, if we go back to the way things were, I know it's going to go dark again, but if we go back to the way things were, then of course what's going to happen is there's no return value. And so if I did write a cout, then this operator would say basically there's no value here, and that would be a syntax error. Because you can't output a void. Also, if we went back and fixed it so that it returns a rational and then we have to star this, then what we could do is we could say t is equal to p plus q, and then we could say, let's say we had another reference to a rational. Let's say we're going to say s is equal to t is equal to p plus q. Now, does that look like it should work, or am I just pulling the wool over your eyes? What do you think? You think that should work?
Yes.
Well, will it work with ints? Can I equal to j equal to k plus l? Well, let's find out. Which is the highest order operator?
Addition.
Plus. Now I have a tie, equal and equal. Now, does equal associate right to left or left to right?
Right.
Right to left.
Right to left. And the reason you know that is because if I say, for example, j is equal to k is equal to 3, right? You know it's going to be this, right?
Yes.
Okay, so it's a right to left association, not a big surprise. So it's going to be here. If this one is returning the value, I can change it, then this return value can then be continued. And this method will be assigned twice. So how many methods would I execute if I extend it this way?
Another one.
Well, you'd have to execute. So this is returning from their 6 method. Now into the assignment operator, we're taking a parameter, so we'd have to do a copy constructor. So that's 7, and then the assignment itself is 8. So 8. It's crazy. You thought I was kidding when I said I'd spend the whole rest of the class talking about it, but I can't. And now you understand a little more deeply, right? So you understand. Okay, you're going to write a nice lab for them using the rational class that we have in R. Okay, so just make sure my rational class is working. And give them a small lab where they have to maybe add an operator and do some small things. You know, so that, because they loved your homework. They said your homework was the best. They liked the grades. So you're instantly the most popular GA. Okay, we're all set.
A question.
Yes.
When you're creating objects, for example, in Java, if you're creating objects of the rational, like rational.
Okay.
set,
Now this. Okay. Now this is a C++ question or Java question. I can answer the Java question offline.